Hi, this is Julie Harland, and I'm your Math Gal. Please visit my website at yourmathgal.com, where you could search for any of my videos organized by topic. This is part 9 of Ellipses, and in this video we use the info we learned in part 8 to do the following problem. So we're going to answer these questions for these 4 ellipses that are centered around the origin. We began with writing the standard equation of an ellipse and learning how to graph it. And then in the last video, part 8, we discovered the foci, what the major and minor axis was, how to figure out the length, etc. And these were the main facts about an ellipse centered at the origin that was a horizontal ellipse. And then the vertical ellipse was very similar. The only difference is the number in front below the y squared, the denominator, was the larger number. So we're going to use this to do some problems now. So let's do this problem. For each ellipse, state the vertices, the endpoints of the minor axis, the length of the major axis, the length of the minor axis, the foci, and then answer this question: is it a horizontal or vertical ellipse? So you can try all 4 of these on your own first by putting the video on pause, or watch me do it. I suggest you try it on your own first though. All right, so here's the first one. Well, this is the equation of ellipse centered. All these are centered at the origin, right? And this is already in standard form, so that makes the vertices easier. Remember, the vertices are, we look at the number, the bigger number in the denominator. So remember, this is really 4 squared and 3 squared. So I could answer this question F first. Is this going to be a horizontal or vertical ellipse? The number under the x squared is the larger number. So this is going to be a horizontal ellipse. Okay? So the vertices, remember, if you want, you could think of this as 4 squared. If you need to write it that way, it's okay. And 9 is 3 squared. Okay, so then this number here tells you the vertices. This is when it's centered at the origin. So we will have 4, 0 and negative 4, 0. Next, it asks for the endpoints of the minor axis, which in previous videos I called those vertices, but they really aren't. The vertices are really along the major axis, the long axis. So the endpoints of the minor axis, we're going to look at this number, and that's on the y-axis. So those will give us 0, 3, and 0, negative 3. Next question is the length of the major axis. It's always double this number. If the major axis is x, so I might just put in parentheses, the major axis is x, right? So we look at the number there and we double it, because we're going from the origin 4 to the right and 4 to the left. That'll be a distance of 8. The minor axis happens to be the y-axis, or it's along the y-axis, right? The minor axis is a certain distance. It's a line segment. So it would be twice the number under the y that's being squared. So 2 times 3 is 6. All right, so all we have left is the foci, and that was something new. How do we get that? We take the numbers in the denominator when it's in standard form, and you just subtract them and take the square root. In other words, c squared is really 4 squared minus 3 squared, but that's really just these two numbers subtracted, 16 minus 9. So if c squared is 7, then c is plus or minus 7. But we have to be careful square root of 7. Square root of 7, plus or minus square root of 7. Is that on the x-axis or the y-axis? They're on the major axis, which is the x-axis. So this will give me square root of 7, 0, and negative square root of 7, 0. It's on the x-axis. And so there's our first problem. All right, here's the next one. Vertices. All right. Well, let's first decide if it's horizontal or vertical. It's in standard form. The bigger number is under the y, so this will be a vertical ellipse. So the major axis is the y-axis, the minor axis is the x-axis this time. So the vertices will be on the major axis on the y-axis. So we have to think of what squared gives you 46, and actually that would just be square root of 46. So this is square root of 10 squared in the denominator plus y squared over the square root of 46 squared. So we've got that the vertices are on the y-axis, 0 square root of 46 and 0 negative square root of 46. Okay, we know that's not, those aren't integers, but you could just approximate where that is. Like the square root of 36 is 6 and the square root of 49 is 7. So this looks like it's a number close to positive and negative 7. All right, what about the endpoints on the minor axis? Then we're looking at what's underneath the x, and that's on the x-axis. So we'll have the square root of 10, 0, and the negative square root of 10, 0. Same reasoning. How about the length of the major axis? Okay, so the major axis, look under the y, you double this number right here. All right, so it's square root of 46. How do you double that? You just write 2 times square roots of 46. And the length of the minor axis on the x-axis is 2 square roots of 10. Almost done. How about the foci? We just subtract the numbers and take the square root, or if you want to see it, it's just going to be the 46 minus 10, right? Because this is the bigger number minus the smaller number, right? So we will get c squared is 36, so c is plus or minus 6. So we just have to decide whether the foci are on the x or y axis. Well, it's on the major axis, so it's on the y axis, so this will be 0, 6, and 0, negative 6. All right, next problem. It's not in standard form, so let's put it in standard form by dividing both the numerator and denominator by 50, so it's equal to 1. So if I divide everything by 50, I get the new equation, x squared over 2, which I'm going to write as square root of 2 squared. Are we okay with that? You could just write 2, but that is square root of 2 squared, plus, then I have y squared over 50. I could write that as y squared over square root of 50 squared. Now, we can simplify that, but I'll do that in a minute, equals 1. All right, so vertices. Now, look at the denominators. Which is the bigger number? It's under the y. All right, so horizontal or vertical ellipse? Vertical, because the number under the y squared is the bigger number. All right, now what about the vertices? They're then on the y-axis, so it's going to be 0 square root of 50 and 0 negative square root of 50. Now, that's fine. That's a little bit over 7. If you want to simplify that, remember that square root of 50, how would you simplify it? That's square root of 25 times 2, so it's 5 square roots of 2. So you could either write square root of 50, or in simplified radical form, you'd have 0, 5 square roots of 2, and 0, negative 5 square roots of 2. What about the endpoints of the minor axis? The minor axis is the x-axis, so that will be square root of 2, 0, and negative square roots of 2, 0. How about the length of the major axis? We take the number, the bigger number here, right, the square root of 50, or 5 square roots of 2, and we multiply by 2. So it's either 2 square roots of 50, or you just do 2 times 5 square roots of 2, right? It's 2 times that number, which is 10 square roots of 2. Okay. For the length of the minor axis, we do 2 times what's under the x squared, right? Square root of 2, so we'll have 2 times square roots of 2. All right, last thing, we're going to have to get the foci. So it's actually easier to get the foci if you think of c squared is this denominator minus that denominator. So this denominator is, well, square root of 50 squared is just 50 minus square root of 2 squared is just 2. That's why I left that as square root of 50. It's easier to get back to 50. So that's 48. Okay, so if c squared is 48, then c is the square root of 48. And we could simplify that by, well, what perfect square is in there? 16? That's 16 times 3, so that's 4 square roots of 3. All right, so we've got c. The question is, which axis is it on? It's on the major axis. Remember, that's the y-axis, so it's 0, 4 square roots of 3, and 0, negative 4 square roots of 3. I don't expect you to get these quite as quickly as I do, but make sure that you go back and try all of these on your own. One more, and this is a little bit tricky. It is almost in standard form because it does equal 1, but what we want to do is just have a y squared in the numerator here. So remember that little trick? If we have 9y squared over 1, I can multiply numerator and denominator by 1/9. Just this one itself, so I have x squared over 1, or 1 squared, plus, all right, the 9's cancel, so you have y squared over 1/9. Now, how could I write 1/9? I could write that as 1/3 squared equals 1. So, is this a horizontal or vertical ellipse? Which number is bigger? Well, 1 is bigger than 1/3, or 1 is bigger than 1/9. Doesn't matter which way you look at it. So this is the x-axis is going to be the major axis, so this is horizontal. So the major is the x-axis, by the way, and the minor one happens to be the y-axis. Okay, so the vertices are on the x-axis. So we've got 1, 0, and negative 1, 0. The endpoints on the minor axis, 0, 1/3, and 0, negative 1/3. The length of the major axis, okay, it's twice this number down here, right? 2 times 1 is 2. And the length of the minor axis is twice this number, so that's 2/3. Last thing to do is the foci. So c squared equals, whoops, doesn't look like 2/3. C squared is big number minus small number, but it's the actual full denominator, 1 minus 1/9. Right? 1 minus 1/9. And that is 8/9. So c squared is 8/9. You take the square root, so I have plus or minus, right? Square root of 8 is 2 square roots of 2, and square root of 9 is 3. Remember, 8 is 4 times 2, so that's how I can pull out the 2 from under the square root. Oh gosh, so how am I going to write that? I think I'm going to need a little more space. Just move all this stuff down, make it a little bit smaller, and move it down so I have room to write the foci. So, all right, foci is on which axis? It's on the major axis. It's on the x-axis. So if it's on the x-axis, we have 2 square roots of 2 over 3, 0, and negative 2 square roots of 2 over 3, 0. Aren't you glad you didn't have to graph these also? So here's just working with the foci, understanding what the major and minor axis is, the length of the major and minor axis, what we're calling the vertices, endpoints of the minor axis, etc. And so you probably want to go back and try these on your own. But this gives you a pretty good idea how you can find the foci, which was one of the main points of this video. Please visit my website at yourmathgal.com where you can view all of my videos which are organized by topic.